I'm gonna roughly just mark through people's work. Okay, the first page, not much to mark lah, okay? It's just give you answer now. So just a reminder, well, let me close, I have a lot of things open. As a reminder, most of the time what will happen is they will print it out in a paper, 你要拿尺来量. So during exam, don't forget to bring ruler. But if you really forget wherever you are sitting for this paper, I think the invigilators will be more than happy to help you get stuff, all right? So I just want to mention that if this is in mm, then this answer must be given to the nearest mm. Change. This one should be given to the nearest mm. But sometimes they disturb you, they will give you this in cm. The unit lah, 它印出来的 unit is cm. So if they print out cm, you will write 2.2 cm, correct? So always double check the unit, but also if the measurement is 2.0 cm, writing 2 cm won't give you mark. It's not correct. You may be thinking, why? Well, the reason is because I want to be able to look at your answer and know, oh, 这个 student 是 use ruler. Because ruler can read to 1 decimal point. Use ruler, and this one, it shows that ruler is able to read to 1 dp. But 1 decimal point in cm. If it's in mm, then no decimal point. Okay, this is an important habit to have because physics were quite strict about this. Your instrument, I should be able to look at your reading and know what instrument you use. Whether it's ruler or other things, vernier caliper. All right. So we hang a 300-gram mass on the spring, and we found that the final length, they type up for you already, is 53 mm. 53 mm. Okay, next part. So calculate the extension using the equation. So what we're going to do is we will take the previous length just now, which is 22, and then we want 53 minus 22, which is 31. So if you take 53 minus 22, you get 1 mark. Very nice one. Bonus. 这整张只是 bonus question. It's bonus. The whole paper is a bonus. All right. And calculate a value for the spring constant using the equation. K is F over E. So 你要跟着那个问题就可以了, just follow the question. They will give you F is 3. So in place of F, you put 3. Okay. And then we have extension calculate already previously. So in place of here, you put here. So then you press your calculator. Right. But I want to comment a bit about what should you write as your final answer. So if let's say I take 3 divided by 3.0 and 3 divided by 31, I'll get 0.09677, right? 3 divided by 31. Actually, it's 0.09677419355. Okay, do I write my whole telephone number here? 整个电话号码写下去? No, please don't. Okay, so what you do is you want to look at this answer here. This 3 Newton is 2 significant figure. When you get 3.0 Newton, 它给的嘛，它已经给了你. They give you to 3.0, which is 2 significant figure. Then this one also 2 significant figure. So your final answer should also be 2 significant. So follow the lead of the question. But the student never round. So should be 0.09.
Teacher, I get 0.097, right?
Yeah, 0.097. So should round. So there's a rounding error here. Rounding error. It's okay. It's very common to have rounding error. So just pay more attention next time. So 0.097. Most of the time, they also allow you to increase the sig fig by 1. So 2 plus 1, which is 3 sig fig. So you can write 0.097 or 0.0968. But anything more than that cannot, or dangerous. Especially for paper 6, because this is a lab paper or an experiment paper. Although you didn't do the experiment, 别人帮你做了。Okay. Next one. Yeah. So follow 2 to 3 SF. Both also can. You want to write 0.0968 also can. But let me double check the examiner report first. Let's look at the other person, whoever that submit first. Okay. So this is okay. This is okay. It will be better if the working was shown. So let me see whether it's a crucial point. Okay, so for this one,
老师1分不了哦。
我知道。你不说也不用紧 because this mark scheme didn't pass. So I follow mark scheme 1. 不是我改嘛，是 Cambridge 改嘛。So it will be better if it's always better to write down one line to show the working. But they allow, so never mind. ECF is error carry forward. For some reason, this answer is wrong. It won't affect the marks from here. Okay. So for this one, it seems like they want it to 2 to 3 SF. So follow the SF. I think 9.7 is okay. All right. Method 2. So method 2, the student pull the mass down a short distance and releases it. So it oscillates up and down. And this is the time taken. So I know this printout is not very clear, but it is minute, second, 03. And this is 1/100 second. So 46. So this one is 3.46 seconds. And it's good that we write unit. I'm going to put S also can. Oops. Okay, this is 10 complete oscillation. One complete oscillation, we will divide by 10. Okay, so if you divide by 10, you will get 0.346, which is correct. And then you square, you will get 0.12. All okay. But this one is missing a unit. So if you square, this one will be S squared. So don't miss out the unit. Okay, for part 2. Unit is 1 mark. So 1 mark for this part, these 2 marks here. 1 mark is for both values correct. And then 1 mark is for both unit correct. So because I can do the teacher thing 0.12 what chicken, cows, tomatoes. That's what you know. All right, so this one is okay, so we put in the equation 0.12 times 0.3 and we get K in 0.1. Let me confirm first. 0.3 divided by 0.12. We get exactly 0.1. Correct? So this is fine, but what will make the answer a bit better, although they didn't insist this. Okay, I want to tell you something first. SPM mark scheme is very standard one. If this year they want you to write the answer this way, then every year after that, they will want you to write the answer this way. It's Malaysia, that's how things are. But for Cambridge, based on the years at teaching Cambridge for A levels and your IG, is sometimes not the case one. So sometimes you don't write unit, they give you mark. Sometimes you don't write unit, they take away your mark. So the answer then here is to always write unit, or just, I guess, hope that they don't penalize you. But they are not consistent now. So I don't want to say no need to write. I'm just saying that in this particular mark scheme, you write 0.1, they will give you 1 mark. Okay. But a better way to look at it is this one, okay, I'm going to write SF in green. This one is 2 SF. This one is 3 SF. 会看吗？后面的0要算，前面的0不算。Okay, we count the zeros at the back, but not the zeros in front. All right. 2 SF, 3 SF. This one should be 2 SF or 3 SF. So basically, we will follow the least SF, which is 2, or plus 1. So it will be 2 or 2 plus 1. So 2 or 3. But this time they didn't penalize. So you can write whatever, as long as it's 0.1 is okay. But what would be better is for us to write this one as 0.100.
Teacher, 0.09810.
What do you put at your t-square? Sorry.
For
What do you
t-square, 0.123.
Oh. Because 0.346 is 0.123 lah. Right? Is that why? I mean, I can even just do this 0.040 over 0.346 square. That's why this part, the working is important. Because your answer and the mark scheme answer may not be the same. And if you show your substitution, I can cross-check your working. And if it's correct, I will give you the full marks, which is 1 lah. So 1 mark also, please show working. Isn't this 1? So this one is 1.0023. So it's 1.0. 1.0, so sorry, 0.10024.
What?
So this is the accurate one. But I understand how you got your 0.123, right?
Yeah.
So 0.346 square. Is this, how do you get 123? Yeah?
I have no idea also because I don't remember how I did it already.
Yeah, you press calculator and see. So 346 square is 0.1197. So 43 is a bit 夸张.
Yeah, wait.
Okay,
Wait,
not going, no, I'm not
wait,
going anywhere. I'm still here. Don't worry. Not going anywhere. All right, let's look at this person's one. This one is okay, no problem. Okay, so this one should be second power 2. All right. So the unit also minus 1 mark. Then this one, right? If you generally look at this, okay.
No, teacher can actually get 0.123 because 0.1225 and rounding for the 25 there.
Wait. You see my calculator. 0.346 square, right? How you get 2?
Oh wait, in the first place I write 3.46 divide 10 equals 0.35.
Cannot, that one cannot.
Mm.
Because, okay, let's go back. When you read this one is 3 SF, correct? So here should be 3 SF. 你要看它的祖宗，它的父母亲。How do you get T? You take 3.46 divide by 10. So if 3.46 is 3 SF, then this one should be 3 SF. Then when this, because this is like parents, children, grandchildren, you understand, right? Here to here, you divide by 10. Then here to here, you power 2 square. So this one should be 3 SF, or you can add 1 for SF. So this student should have written 0.1197 or 0.120. 120?
是我的这个
0.120. Yeah, 20. Yep. But let me check my friend the mark scheme. The mark scheme doesn't allow more than 1197. So it's can lose mark lah. If they want a minus, it's not clear. So basically the answer is depends on the discussion. It's risky to not follow their convention. Because sometimes I ask the examiner that come and train us, you minus or not? Then he's like, discuss within your examiner group. Like that, then I must make sure I follow what they give me. So it is either given this or this. They even allow this, although this one should be wrong. So they are not consistent one. You just follow. If they say 3, you follow with 3, confirm okay. So just follow them. All right, calculate the spring constant, K. Again, this one, you need to show substitution. In this case, you don't show, also never mind, but showing is better, especially in the case of like what you really say, sometimes when you didn't round correctly and you don't show substitution, I cannot check what is the reason why your answer is not the same. Unless you're very sure that your answer is the same now. Then okay. 0.100. So generally this one 从这边来. So this one is also 3SF. So the whole idea of doing this question is not just training you how to practice using the equation and also substituting, but also be a bit aware of things like unique and significant figures. We will have plenty of time to practice this. Right, one last part. State and explain whether your two values of K are the same between the limits of the experimental accuracy. Okay. So we found two values of K, got two methods, right? Method 1, where we measure the extension, K was 0.0968 Newton per mm. Method 2, K is 0.100 okay. So results are very close. Ken, you mentioned very close or close enough or nearly the same. Then you can write yes. Teacher, can I write no? I think it's very far. Okay, Ken. You can also say results are far apart. So this one is GG one is arbitrary. So it depends on you. So basically your explanation must match your statement. I think they are nearly the same. Okay. There are more standard ways to do this, but then it involves extra calculation, and I don't think you want to do extra calculation. Okay, so statement here you say is not the same. The numbers are smaller in second method, and the most numbers. What do you mean by the most numbers are integers?
我不知道讲解释就
Can
在
speak
method 1
Mandarin.
里面的号码，
嗯。
算出来的东西全部都是没有小数点。
哦，那个是 coincidence，刚刚好 ，just happen to be like that。诶，这样的
有这样的，所以我才要讲写出来。
So if you want to say it's not the same， 你要这样子讲的话，你要讲哦，我的 result show that 两个 K 不一样。The integer one is 刚刚好罢了 ，is a coincidence. It's not confirmed. So what I could say is that both K values are far apart. So student A and student B, the answer can be different as long as the explanation match the statement. You say it's not the same, then you must say they are far apart. You say they are the same, then you must say they are close together. But teacher, how far apart is far apart? How close together is close together? I got methods to calculate, but that one is A level and this is 2 marks. But a general rule of thumb is if the difference is more than 10%, then we can say it's far apart. General rule, but 你要算呢，不用算啦，没有分东西不用算。Okay, So they will take any answers as long as your explain and the statement make sense. So in this case, how many integer you have or how many significant figure you have, it doesn't have anything to do with whether the answer is accurate or not. Accurate 就是准. It only talks about whether your instrument is sensitive or not sensitive. Okay, last part. A student states that repeating method 1 with different maths will improve the reliability. Okay, I need to talk about this kind of term. Accuracy is 准啦, close to true value. So for example, if let's say the height of my friend is 171.2 cm, and then every time I measure my friend, I get 171 or 172, and then I measure again, I get 171, 171, 172. I will say my reading is accurate and reliable. You can also, oftentimes this is represented in a bullseye diagram. So I'll find it. Like that. So this one is reliable and valid. Let me place this here. Reliable and valid, or in this case, actually, let me go and find a nicer one that's not so reliable. It's like you are shooting something, you know, like shooting an object or a bullseye, like that. So whenever you take a reading, right, in the lab, what you are doing is you are taking measurement and hoping that it is 准. 准 is accurate. So this is precise. I'm going to just delete this because the terms are not the same as yours. So this first reading here, we can say it is accurate. Accurate and reliable. So if I have sniper number 1. Sniper 1 is what I want to hire to kill my enemy because he is accurate and reliable. He shoots what he wants to shoot, and every time he shoots, he kena. Good. So accurate and reliable. So reliable means whenever you repeat the experiment, you get the same reading or close to the same reading. So that's why the dot all very close to each other. So reliable here means repeat experiment, we get the same result. Reliable. Like your PCR or your PCR test is more reliable than your antigen test.
Reliable 也是好像 consistent 这样啦。
Consistent, 对. So the Cambridge, they don't use the word consistent, but I'll write this here because I know SPM use consistent. So your PCR test consistency or reliability is around 85%. The antigen tests are the one that you use your saliva one, then you put in the solution, then you delete one. That one, the line, the double line, that one is a RTK test because it tests the presence of the virus inside your mucal lining, basically your cell, okay? But it is not actually scraping out your cell like what you do in the PCR test and actually sequencing the DNA. So it's a different process altogether. So then you might be saying, then everyone should take PCR because PCR is more than 95% reliable. But the problem with PCR is that the result takes 24 hours. You may not want to wait 24 hours. So if let's say I can do a test and 85% of the time the test is accurate and I can get the result in 5 minutes, I want to do that test and it's cheaper. So not always 我们要 aim for the most accurate, most reliable. Sometimes we will choose a cheaper or a faster method if the accuracy and the reliability is still within acceptable range. 还可以接受啦。You test 10 times, you test 100 times, 85 times correct, not bad, right? It's okay lah. It's not ideal, but I don't mind. I test again. No? I test again after a few days. So accuracy and consistency. So sniper number 2, this one, this is not accurate because it doesn't hit the bullseye at all. But it is reliable or consistent. So I guess if I hire sniper 2, and then let's say I want to murder person A, I will just tell sniper 2 aim for person B, and then 他就不小心射到 person A. Okay, can joking lah. So this one is not accurate but reliable. Normally this is 0 error. Your meter got reading, stuff like that. Person number 3. This one is accurate, okay, if average is taken. So if I take average, meaning I repeat several reading and then average this 5 should be somewhere in the middle. Okay lah, can. So if let's say, for example, your RTK antigen test is not very reliable, you take a few readings. All right, and then this one, number 4, is what is this? Not accurate. This is not reliable. I would say 3 is somewhat reliable, but not as reliable as 1 and 2. So just not reliable also. Because 它每一次射的地方不一样. Every time it shoot different things. Every time I measure different value. Okay, so this question, this part here, it says that I want to repeat method 1, which is I hang the mass to the spring so that I can improve my consistency or my reliability. Basically, 每一次我 repeat 那一个 process, 我算一个 K. When I calculate the K, it's like I make a dot on my board for the spring. Okay, so suggest the additional value for the mass M that you would use when repeating the experiment to improve the reliability. So like what values of M should I use? So if accurate is 准, then consistent is what? What is the Chinese term? I forget to ask because I don't know. Consistent. If a person is consistent, what do we say? What term to use? Also 准 lah. Cannot be like this, is it? I don't know, but they don't describe the same thing, essentially. Anyway, so suitable values of M. Okay. They say additional values of M. So we need more than one value. I'm just gonna look at the other answer and see what are the add 60 grams. Additional values, more than one. Okay. So we hung how much mass did we hang? 300 grams. Okay. And if I think about this, I need to make sure that the spring, if let's say I go and put 2 kg, I might spoil the spring. Okay, so we need to think about what is realistic to add in the school experiment, but such that when I measure, the difference in length is big enough for me to notice. So if let's say I add 1 gram or I put 301 gram, 可能我量不到它的 difference. Maybe this will just be 53.2 mm. Okay, so I need to be able to have like a large enough difference just to make sure that, okay, if I put 300 grams, my K is 0.1. But what if I put 50 grams? Is my K still 0.1? What if I put 100 grams? Is it still 0.1? 200 grams, is it still 0.1? Okay, so you can put any value between 50 grams to 600 grams. And then you should have at least 3 values. Teacher, how I know what value to put? This one is unfortunately, and I will quote the examiner report here. The range of masses must be realistic for the experiment performed in a school lab. Basically, I know you cannot put 2 kg because a 2 kg slotted mass doesn't exist. But I don't know if you know. But maybe I only know because I'm a science teacher. I play with slotted mass and you may not know. So this one, that's why we must do a lot of questions to either level up our experience or go to the lab. But any 3 value that is, so cannot be like 51.5 gram. So if you think about slotted mass, right, let me show you slotted mass. Slotted mass. Yeah. This one. I record the slotted mass. There we go. So the slotted mass that we are using is okay. So now we're going to look at me. So I will show you quickly. I'm making arts and craft here. Where's the picture of my slotted mass? So that's long. I didn't expect I need to show you slotted mass today. But I did remember doing it this week with my students. Let's see if I can find it. If I cannot find, then this one. Slotted mass. Picture of this. Okay, so no slotted mass. Okay, anyway, we can tell the slotted mass I can increase in increment of 10 grams. You need to look at the thing, but unfortunately, you don't necessarily have time to actually look at the instrument because you are learning online and I don't know when you can go to the lab. So the only way we can settle or we can give you that level up chance is to practice questions. Okay, so additional values. Later when you try question, I go and find picture. I got picture one. I told myself, I remember. And I show my student just Friday, but now I don't know where is it. Okay, anyway, additional values here always have. So for SPM standard, they normally want you to write at least 6 for SPM. Later in Form 5, Form 4, your teacher will talk to you about this. So at least 6. For CIE, they want 3. You just write more than that. So you can put 100 gram, 200 gram, 300 they use already, then we use 400 gram, 500 gram, 600 gram. Okay. So the mark scheme will look like this. At least 3 additional values given, and the value have to be logic. 在 lab 里面可以做的东西，你放太重不能，你放太轻也不能。So generally, as an idea here, slotted masses in the lab. So hopefully, as we practice a bit, day by day, we will be able to get a good sense of what is in the lab. So slotted masses, normally you will have 10 gram, you will have 50 gram, and then you will have 100 gram. And normally in the lab, you can multiply this depending on how you stack them. So you can actually put values like 110 gram, 220 gram. I still need to give you marks 1. So as long as the value is between 50 to 60. But the slotted masses given is this much. The hook, where you put the slotted mass, this thing is 50 gram. Okay. All right. That's it for this one. We will carry on a bit and look at another new subtopic. So this paper 16, we will keep taking time popping in, popping out again. But meanwhile, we have to grind the syllabus. So let me do this. You mark yourself, okay? Yeah, slowly you will imprint the whole mark scheme in your brain one. And then you go like, oh, I'm thinking like an examiner, meaning you won't lose mark already. Okay, so this section is very long. You have to learn 13 things, GG, all right? And it may seem that we're perpetually in this section, but this section is also important. You will expect one paper 4 or one structure question and 2 to 3 objective. Almost confirm one structure and 2 to 3 objective. Now, the annoying thing about your A-level books, right, is that they don't classify their topic following the syllabus. So you will get very confused because when you open the textbook, this one may be chapter 2, but then it's 1.2. I follow the syllabus because we are learning this syllabus, but if you look at the textbook, remember to always refer back to the syllabus. And if you're not sure, just take a screenshot and ask me. Okay. So here, in motion, we are basically doing this field of study called kinematics. We are ready to do some physics. So previously, what we did was we looked at, in the previous class, we learned to measure length and time. Measuring length and time. But why should we bother about measuring length and time? Because we want to be able to use our measurements to describe 形容 motion or movement. But because we just started only, so we need to start with level 1. Level 1 means motion in one straight line and in one direction. So 没有退，只有前。Move in one direction in a straight line. But teacher, I can turn around, I can move in a circle, I can move in an arc. Yes, I know, but we start with level 1. We don't change direction and we move in a straight line. Okay, so if you want to describe motion or movement, we will start to learn the key terms. Number 1, starting with the idea of distance, which is actually a measurement of length, distance, and the term displacement. So I understand that if, let's say, you are more fluent in Mandarin, then learning the English is also part of the process. I think distance is a fair enough understanding of what it is. And let me find a picture for you so that we can visualize this together. Let's see, screenshot. Oh, by the way, we don't just measure length and time. We also did some density calculation. Just as a reminder that we did that. Okay. So let's say I have an object. Let's say object A. And I know I say we move in a straight line. It's my part. One straight line. But object A, and let's say this is from point 1 to point number 2. Maybe this ball will roll from 1 to 2, but it rolls this way. It's a bit like you drive to your friend's house and you start your Waze, and your Waze tell you, oh, it's 11 km. But actually, it's not. Let me pull open Google Maps for you to see. I don't know whether you notice this or not, or you open Waze, or you can just try Google Maps. Let's say, for example, from my house, I want to go to 1 Utama. So I click. Okay. So if I look at directions, right, and then maybe I choose my workplace. Okay. So you notice that it tells me 2 very important information. It tells me how far it is that I have to travel. You can see. Okay. Oh yeah. Let's start with Catholic High School. Since she was like leader. Okay. So 16 minutes, 7.9 km. So this tells you that your car needs to travel a total distance of 7.9 km. This blue color length is 7.9 km. I'm going to, this one boring. We go from Catholic High School to 1U. Okay. So This 7.9 km is distance. The real distance you need to move your car, including all these turn, U-turn, turn out from the housing area, turn into section 17, move in a straight line, then U-turn into 1U. All this is distance. But you know what is displacement? Displacement is when you helicopter. Let's say you can helicopter. So you will travel in a straight line from your school to 1U like that. Wow. Not bad. For helicopter, your private helicopter, you travel like this. So distance is your 7.9 km, but I'm pretty sure the length of this red line is not distance. This is displacement. So this is the difference between distance and displacement. Distance is 你真正的跑的路。Displacement 就是 you take the starting point, you take the ending point, you draw a straight line, that length of the line is displacement. So when we define this, distance is defined as the total path length. Traveled. Let's say you have a car. You want to go to 1U from your school, travel by your car or travel by the object in motion. Okay. Displacement is the shortest distance between the start and the end of the motion. Which one will we study? Maybe both. We got to read the question. Okay, so symbols that we use for these two, because you know in physics we lazy to write distance and displacement repeatedly. I think this is quite small. Let me make this bigger for you. So in physics we prefer to use symbol, lazy. So we can use D lah, can use S lah, can use X. These are the common ones. I prefer to use S because I learned it in S, but it doesn't matter. Just know the symbol can already. All right. And read the question. They will normally help tell you what symbol they are using. Unit that we use here is meter. Let's say SI unit is meter. All right, so this is number one. We look at 你跑几远? How far? How far away is 1U? Different answer lor. 7.9 km. If you decide to go this 12.3 km, then you okay lor. Go through village park to get some nasi lemak. I don't know. Right. Number two. How fast? How fast? We use the term like speed. 你跑几快? And speed here can be defined as distance divided by time. So the distance that you travel divided by how long it took you to get there. Did it take you? So in this case, if there's no jam and everything is exactly as predicted by Google Maps, I'm going to take 7.9 km divided by 16 minutes. Then teacher, what unit I have? km per minute. 好奇怪的 unit. Can write meter per second? Can. So you can put 7.9. Kilo is 1,000, so you times 1,000 divided by 16. Minute, you want to convert to second, then divide by 60 second. This is meter. Let me press my calculator. 7.9 divided by 16.
Teacher, don't you have a digital calculator right there?
But then it's faster to press my mechanical calculator. No meh? Digital use mouse and press. So this one is 16 minutes. What nonsense? 16 minutes is 16 times 60 seconds. No wonder my answer make no sense. Okay. So I have with me 8.2. Just gonna put 8.23 meter in 1 second. Okay, quite fast, no jam now. From your school to 1U. No jam. Only here a bit. And then some of you who actually sit in car one, you know, teacher, can I that one meh? 我停在那个 traffic light, 我这边 jam 一下子 I slow down. Then here is highway, I can speed up. Confirm must be more than this, and then sometimes less than this, right? Yes. So what we are doing now, when we calculate this is actually average speed. Okay. So to find average speed, I'm just going to write this. Average speed, this will be total distance divided by total time, which was what we did here. So I cannot tell for sure at 10 minutes how fast the car is going. I can't tell from this data of Google Maps. I need more information. Teacher, where do we get more information? We draw a graph. So part of the skill that we did last week was learning how to write decimal point and etc. So today, the extra paper 6 skill that I want you to practice is look at graph. How to read the graph. What is a graph? Okay, so we'll look at that a bit later. But since this is average speed, then if you want to find the actual speed, the general equation is distance to time. So I better tell you what the symbol is. Symbol, you see, most of the time we use B. Or we just write the word speed. And we seldom use this later on in the later years if we do physics. But we use B. I guess you can use S, but then it will be confusion with this one, so I will probably not do it. SI unit will be meter to second. 因为你拿 distance 的 unit 是 meter, and then time 的 unit is second, so meter divided second. Okay, so if they ask for average, then you total everything. If they ask for a particular time, then you take the distance divided by that particular time. So this is the answer. How fast? How far did we go? And how fast are we going? All right. So we should try some questions now. Okay, I don't know if you are the I like to hard copy kind of person, but if you are that person, and I'm sorry, you will have to find, because I pick and choose questions one and not very consistent. So okay, you can find it from here. People talk to me in the chat. Let me see. My house near 1U. Displacement is the straight line. Yes, closest distance. Shortest distance. So shortest distance have to be straight line. You imagine you very rich, you got helicopter. 你要去学校，不用 jam， 不用等 traffic light, you just go up to the road, see the helicopter straight line to the house. Best
Okay,
line.
but another problem is how are you supposed to get down?
You very rich ma. You commission a helicopter pad in your school now?
用 ladder 啦，爬下去啦。
Or you
很危险的
parachute
枪。
you parachute down.
Where you put that parachute? You put it in your bag, man, very heavy leh. And how you get up later?
And why you want to waste money with a helicopter? Just drive to school lah.
But teacher need to 玩要来玩要去耶。
Don't know 只是很好笑罢了. I just feel it's very funny. That's all. But yeah lah, this is life, the life of some people. Okay, we're gonna look at some questions, but I think I'll start with objective. 可以直接飞过去, or even nicer if you can teleport, like the Doraemon car. Doraemon car? No, Doraemon door. The door where you can just fly from point A to point B. I think we should do a structure questions. Okay, who's that? All right, so we're going to look at Okay, to find this, you go to Discord, and then you go to the library, and you see here the Word Drive to textbook. Click this one. And this link will pop up. See, it's topical. It's topical. Paper 2 is objective, and paper 4 is structure question, and all of these is your textbook. 对啦，你可以 download 啦，你不要 download 也可以 ，up to you. You want to print also can, but it's 1,000 plus pages. I am not going to discuss all, obviously, but I will probably discuss some. So I think I will start with paper 4, page 34, and I'm going to paste the question here. Then I will assign homework from there. So basically, all the question we do is 直接就 practice 了, unless I feel that we need to. And most of the time we don't.
Teacher, what is P4?
Paper 4 law, structure question. You do all the even paper 2, 4, 6.
Do question 4. That one so long. I don't know how to do it.
What question 4? This one question 4, meh? We do together, don't worry. Okay, so here, remember I say we look at the graph. So this is our girl, and our girl is riding her bicycle along a level straight road. Remember how I say things are mostly going to move in a straight line for us? The graph shows her distance against time. Distance against time. Teacher, what does this graph mean? Well, this graph tells me, let's say this is the girl's house. Actually her house is here. So I'm not going to even try to draw a girl on a bicycle because I don't think I can do that. I shall ask my friend. Girl on bicycle. My friend is.
Teacher, just let me draw already lah.
You want to draw?
Yeah.
Where you want to draw? Okay, later I crop and put it there. Girl on bicycle, please. So while Yuri draws her girl on the bicycle, you can look at this graph and try to figure out what the graph represents. What does this graph mean? Like, what information can you pull from the graph? This is what, okay lah, can lah. Okay, girl with bicycle. Screenshot. Thank you. Okay, so I'm going to clear the annotation. And unclear all drawing. No, I do not want to annotate. Okay, so this girl with bicycle. Oops. Okay. So this is where she is at now, 0. And then at 10 seconds, if you look at this graph here, you read from 10, and then you ... You extend to this point here. This point is 3 boxes. Here to here is 10 boxes. 10 box is 100. So 3 box will be 30. So this means at 10, this is t equal to 0. Our girl is here. And then when t is equal to 30, our girl will be here. T equal to 10. And then the distance that she traveled, let's say I measure from her head to her head. Here to here is 30 meters. Okay, Mo. This is what it means. In 10 seconds, travel 30. In 20 seconds, travel 115. In 30 seconds, travel 210. I think you get the idea. We can read it at any given time, all the way until 60 seconds. So there is a lot of data that I can pull from the graph, if I need to. But this is generally what it means. Describe her motion from A to B. So when they say describe, right, motion, we are talking about statements that has to do with speed. So if I want to describe her speed, I only got 3 ways in describing the speed. I can either say the speed is increasing. So increasing here means she is moving faster. I can obviously could say that her speed is decreasing. In this case, she's moving slower. But I could also say her speed no change, constant. So doesn't change. So let's look at the first part from A to B. A to B is this side. Do I tell whether the speed is increasing or not? Well, good news. I can find the speed at 2 random points. Let's say here, since I got this number already. So at 10 seconds, the speed V, all right, here, speed V is distance to time. Time taken. So at this point, this V is 30 over 10. Let's say I take point B. Point B is 15. And this value here looks like, this is 70. And this V here would be 70 over 15. I think 70 over 15 is bigger than 3, right? This is 4.7, and then this is 3.0. So I hope you can see that the speed has increased. And then, of course, you may be wondering, teacher, I need to show the calculation. So give me one line only. I say it's no need. You should be able to tell that, you see, it took me 10 seconds to go up 3 boxes. And then it took me another 5 seconds here to here to go up 4 boxes. Of course, I am moving more. First 10 seconds, I move 30 meters. The next 5 seconds, I move 40 meters. Of course, I'm moving faster, right? So from A to B, you can say that the speed is increasing, or the girl is moving faster. Our speed is increasing. Okay. What about B to C? And I don't know about you, but B to C looks like a straight line to me. And I don't know how much maths you know, but a straight line tells me that all the speed is the same, or the gradient is the same. But if let's say you don't know, then what we could do is we can check out 15 to 20 seconds. So let's say I zoom in a bit and I check out from here to here. In 5 seconds, here to here, I move up 4.5 boxes. I'll draw an arrow for you to see. So we are talking about here to here is 5 seconds. And I move up 1, 2, 3, 4, 4.5 boxes. Or 45 meters. 5 seconds. Can divide, can. This 30 divided by 10 is minus 0 的，因为我们从0开始算。17 over 15 also minus 0 because I'm taking from here to here. I don't know whether this triggers any memory, but I'm actually looking for gradient. I take the height divide by the base. Anyway, let us check in on, I guess, close to point C. So from point C, this is 45. I'm going to count 5 boxes, 1, 2, 3, 4, 5, which is here. So here to here is 5 seconds. And I wonder how far have the object traveled? 1, 2, 3, 4, 4.5. So here to here is still 45 meters. So the speed here, V, is 45 divided by 5, which is 9, right? 9 meters per second. And here is 45 over 5, which is 9 meters. So never change because this entire line is straight. I will summarize for you. So if the line is straight, whenever you move 5 steps, you will go up 45 meters. You move 5 seconds, you go up 45 meters. You move another 5 seconds, 45 meters. It will be the same because the line is straight line. So in this case, I will say that the speed, they just asked to describe, they didn't ask to explain. So I can just describe and call it speed is constant or doesn't change. All right, from C to D. Let's look at C to D. What can we say about this part of the graph? You could obviously take 5 seconds again. Maybe I'll take from here 2, 3, 4, 5. Here to here is 5. 5 seconds here. And then I noticed that we went up 3 boxes. But then if I go and take 5 seconds here, of 1, 2, 3, 4, 5, I only go up 1 box. So I went from 30 over 5 to 10 over 5. 6. 6. 30 over 5, yeah. And then this 10 over 5 is 2. So in other words, the speed decreased from 6 to 2. No need to write value. Just need to say speed decreases can. If they want value, they'll ask you to calculate. Speed is increasing until 0 at t equals 16 seconds. You can also say speed is increasing from 0 at t is equal to 0 seconds. Okay, so it may be a little bit confusing or maybe a little bit intimidating if I tell you we have to calculate all these values that I just did. So the outcome here is not so much that you need to calculate. Look, if they're not going to give me marks for it, and I don't need to do it to protect my marks, I'm not going to do it. Does that make sense? Because we have a limited amount of time to do the question, and you sort of don't want to waste that time. All right. So the way to look at this, right, is to look at this thing called the gradient. Okay. And to help us understand what gradient is, I'm going to show you a simulation. And I will, at the end of the class, put a class post here, class recording. I dump everything inside one. Okay, then I'll add another list here called simulation or resources. Okay, let's look at our boy here, our friend. So gradient is CA2, CCA. So you notice that gradient got positive and negative one. All right, can I slow you down? Let's slow you down in a second. All right, so let's say I start from the top. Okay, I pull you back. So right now, our graph is always positive. So the shape of the graph sort of looks like this part here, right? This part here looks like the shape of our graph just now. I'm gonna make my dude come here first. Okay, so if you look at him, here the speed. I pass here. Hang on. Why no pause button one? Just seconds. Okay. All right. So we're gonna slow him to here. Okay, there we go. This is 0 gradient. I'm gonna crop all of this so you can see. So when the graph is like this downward portion here, this is zero gradient. So I'm gonna put this side by side. Okay, this part is this part of the graph. This is your point A. So this part is your point A. This one is flat. It's as if it is not moving for a short period of time. 它是平的，没有走动。That means time has passed, but I haven't increased my distance. So at this point A here, gradient 0, meaning your speed also 0. So time has passed, but I haven't moved, not moving. For that very short point in time, it's as if 你停了一阵子。Have you started riding a bicycle? That split second before you start moving, it feels like you're not moving, right? That is the split second. Okay. So our friend is now going to move. And as he moves, I don't know how I'm going to crop this. I adjust now. So as he moves, zoom in. Oh my God. As he moves, increase the speed a little bit. You will notice that the gradient is slowly increasing. This green color line is getting steeper and steeper. So from 0.9 to 0.22, 0.25, 0.26, you can feel it, right? If you're going on a roller coaster, it is getting steeper. So this steeper here is increasing gradient. Okay, so I'm going to pause this and screenshot this part. So my friend here, you can go cute roller coaster ride. Where shall I put you? Let me put all this in one place so it doesn't look so messy. Okay. So here gradient 0, speed 0, and then I'm going to reach here. This part here, as he travels to this point. So point B is probably somewhere here. This is B. So between A and B, this green color line is getting steeper and steeper. So we will use the term that the gradient is increasing. Or in other words, it's getting steeper. The roller coaster getting steeper, 斜一点，越来越斜, meaning the speed is also increasing. To interpret the gradient of the graph can be quite scary, but very, 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 very important in science, in all your subjects. We can start learning now. Okay, if you haven't learned yet. So this is B. So we're going to turn. And eventually he will reach a point where the speed, or if I check on this dude, my dude here, I'm going to make him move a bit faster. So you notice that this one will increase to a certain value. And as this green color line gets steeper and steeper, you will reach a point where it doesn't increase anymore, which I hope is 1, because there will be perfection. It's not 1, it's just making me disappointed. So it increase 1.1, 1.5, 1.6, 1.8, 1.2, 1.3. So you can see this one here. Okay, it's not really working, but meaning this one is still increasing, but we shall ignore that because it looks constant enough to assume it is constant. So this point here, remember our B was here, and then our C is somewhere here. So you look at this green color line. This green color line is the same as the graph. So from B to C, we can say that the gradient is constant. It's as if the line doesn't get steeper or less steep. Okay, let's play it for a while. So if you look at this part, it's as if this line stay the same. 1.38, 1.38, almost the same now, okay? 1.39, 1.4. So it sort of stays the same from here until maybe somewhere here. But what happens after that? Let me speed up a bit. So as it goes to this point, you notice that it will begin to flatten out. It'll take a while. Let me double the speed a bit. So when he reaches the top here, you sort of notice that, hey, this line is not as steep anymore. It's getting flatter and flatter. So not, it's getting flatter and flatter and flatter and flatter to somewhere here. News fact. News fact? News flash? Okay, here. So from here to here, this point was your C. And this point is your D. So from C to D, right, the gradient decreases or decreasing, I guess. So because gradient decreasing, speed decreasing. Later I fast forward, you can tell that his speed is decreasing. Speed constant. Okay, and the final portion at D. You reach a point where it will totally flat one. So somewhere here. Okay, almost flat, negative. Okay, so it is at this point. I'm not going to go through it again because I don't have the patience. It is at this point here where it's completely flat. That gradient is constant. So A, B, C, D, this is point D. At point D, gradient 0, speed 0. Okay, so in other words, right, whenever you sketch a curve this way, it gives me a lot of information. From A to B, 你看这边越来越斜. You imagine you slide up this on your, I don't know lah, your roller coaster, your Hot Wheels, your bicycle, whatever. Here to here, gradient increase, steeper and steeper, speed increase. Okay, if you look at this section here, it is getting less and less steep, 越来越平. So from point C to D, here to here, gradient decrease, speed decrease. And then finally, this middle portion here. If, I mean, obviously I freehand draw 没有 the straight line lah, but if this is a straight line, then here is what I'll say, constant gradient, constant speed. Constant is just a term to say it doesn't change. Speed no change, gradient no change. You can very easily write this as no change. It's fine. You don't have to use those words like constant, but they will use it, so it's probably important for you to know how to use it. Okay, so we are looking at the shape of the graph, and if we just do some past year question shopping, please, can I memorize? One day your graph look like this. Then your graph look like this. You want to memorize? Seriously? Then your graph will look like this. And then your graph may look like this. Nani? Don't memorize. Cannot. 你要 chop it up into section and part by part analyze. So in this question, because it's the first question that we are doing, I chose the easy one where they already chop for us. A to B, B to C, C to D. They chop for us already. Later, we have to learn how to chop ourselves. You see, they never chop for us, GG. So we have to figure out, okay, from where to where is constant, where to where not constant. For this case, if you have a ruler, it's easy to tell, you just put the ruler there. So maybe next time when we do this, or next class when we do this, I will teach from my iPad, because I can put a ruler on my iPad app, but not on my digital tablet. So I don't know how to do it. So boomer problem. Okay, anyway, let's finish up the question. Average speed from A to B. Sure. This graph is very like a lot of things happening, you know, from A to D. We spend so much time staring at the graph and deciding the gradient, speed decrease, increase, constant, all that. How to find the average speed? Do I need to like find every single point in time and then look at find the average? No need. When I see the word average, I think of total distance over total time. Average mark is total marks divided by total subject, right? So total distance over total time. You don't need to write the equation, but you must show the working, okay? So how far did our girl travel? Our girl traveled 400 meters. I don't care, faster, slower, speed up, constant speed. How long did she take? 60 seconds. So 400 divided by 60. I better include the unit. Meter divided by second. Because, you know, units. Not. Life's pointless. Okay, good. Wow, this number a bit sad, but it's 6.667 meter per second. Okay, meter divide by second, you can write like this.
这个是那个6.66666这样的，这样67就可以了，还是一定要写多一点？
不用，够了。
OK，
因为你看你这个你读400是 3SF， 所以你这个你收 3SF 就可以了。Do not leave your answer in fractions. 20/3是 confirm 错，因为 physics 我们要看 SF， 我不懂 20/3多少个 SF， 因为我们也不知道那个 SF。So it's about accuracy. 我从 graph 里面拿到的 data， 我可以读到几准，我可以读到400或者是390。So all this is around 3SF. So I should keep it at 3SF. 如果你放6.666666667，就好像包假的 accuracy. It's like you're telling people that, oh, I can measure so many decimal points. My answer is so accurate, but actually pick one fraction with a lot of decimal point. That's why we care about the SF. Or we are training you. I think in IG they are a bit lenient, but in A level, I got students who will lose a lot of mark because SF never can. So practice, learn to practice. Okay, last part, maximum speed. Okay, can someone tell me where is it the steepest? Maximum speed. Now, speed is gradient. So if we look at speed, we can look at the gradient of the graph. So where is the gradient the steepest? Okay, maybe you can give me a time. Where do you think the graph looks the steepest? Where do you stand and then you feel like, wow, 这个很斜，最斜的点在那里。Give me a time. There are more than one answers. Which time? Which time? I zoom in for me now. Where is it the steepest? When is it the steepest? It's the better answer. There you go. Any thoughts? 哪里是最斜的? Okay, maybe we can look at our mustache guy, hat guy. Where does it look like the steepest, especially at this portion? I cannot zoom in. The simulation is a bit dead. So where does it look like it's the steepest? Where this line look like it's the steepest point? 30 seconds. Okay, good thought. Somewhere here, right? So 30 second can, 40 second can, 20 second also can. Basically, it's the entire portion from B to C. Here is the steepest. So we just need to take distance divided by time. You want to take B to C also can. You want to cut halfway also can. You can take anywhere lah, all right? So we already calculated one. here. See? This one is 9 meters per second, 45 over 5, 45 over 5. But now we draw big one and see whether it is indeed 9. So I'm going to take point B and C. Okay. Any time between point B and C is okay. So to find gradient, I draw a triangle. Okay, to find gradient, I'll draw a triangle. And the triangle is a right angle triangle. And then I take the height. This value here is 350. And this value here is 70. So the distance from here all the way down here is 350 minus 70. That's why it's 3 marks. Can put 350 minus 70. Okay, divided by time. This distance all the way to here. Okay, I think it looks quite nice because this is 15 and this one is 45. So 45 minus 15. You can write like this, you can minus first also can. So 50 minus 70 divided by 5 minus 50, I get 9.33 or 9.3 meters per second. It's close enough because we estimate. Okay, so you can write 9.3, you can write 9.33. Because 45 and 15 is 2 as well. So it's up to you. Normally I'll stick to 3. Okay. So I'll make a note here. To find gradient of something, you will take the height, basically the y-axis, the change in y-axis, or the vertical axis, divide by the base, or the change in x-axis. Right angle triangle must be drawn. Okay. So normally the 3 mark here, okay, later I'll rearrange because I know different people are copying different stuff. So 1 mark is the triangle at the right place. How you're working mark. 1 mark is the substitution based on your triangle. Substitution for gradient. And the final mark is the answer. If the answer is between 9 to 9.5, you are okay. Around there. Because 你读嘛，你是 estimate 到的。Okay. So I'll print this whole thing. I throw inside Google Drive one. So if you didn't copy anything, don't worry about it. You can always catch up later. Okay. But what we have done today, besides reviewing stuff around significant figures and decimal point, is to look at graphs and understand that graph can give us a lot of information and sometimes too much information until we don't know how to look at it. All right. So we are interpreting the graph in the context of distance and speed. Distance meaning how far you travel. Speed means how fast you're traveling. Okay. So to find speed at any given time, you can take, look at this one. Oh, this 5 seconds, I travel 45 meters. So I can just take 45 divided by 5. Then it is the speed of the bicycle from point B to here. Okay, so I just need to find you travel how far and I divide by how long it took me. But if you want average, then I will just take the total, divide by the time, 400 divided by 60. And the important takeaway here, or the new thing, is this idea of gradient. So based on the shape of the graph, we can tell the speed. If the graph is flat, speed is 0. If the graph is steep or getting steeper and steeper, let's say A and B is getting steeper and steeper, this one, your speed is increasing, speed is constant, then speed is decreasing. So the main thing besides learning all of this is to understand how to interpret the shape of the graph. 怎样看它的 gradient 有增加还是有减少, and then how to find gradient for straight line. Teacher, if the line not straight leh, that one later lah. So you can also take this like a cheat code. 哎呀，每次还要我找 speed，我就找直线的地方。Also can. Also can. The cheating, not really physics, but more like hacking the system because you are looking at mark schemes. All right. So I'll assign maybe 2 to 3 questions, not too much. What I'll do is it will look something like this. And let me peek at the other class. All right, it will look something like, probably look something like this in your class recording channel. So I'll screenshot the question. What you want to, how you want to do is up to you lah. You can annotate the numbers and fill it in. You can print it out, or you can. I will also put the page number. So you see, I'll include the page number. So what you can do is you can just go to document and look up the page. Okay, 2 to 3 questions. So probably we'll spend about half an hour of the time reviewing. That should be enough. Okay, any questions, you can always talk to me here. Disturb me, or you DM me or something. All right, that's it for today. Thank you. Your brain okay not? Or gradient infinity, vertical line. Vertical line is infinity gradient. 超大, 超大 like that. Infinity is like this, 0 is flat. So this one is supposed to learn in maths 1, but I know you have you learned this in maths? Don't know. Okay, so I assume no. That's why I teach like that. If you learn already, then I will probably just teach faster. Okay. I screenshot attendance and then I will throw everything into the classroom. Charlene 不见了. Okay, I will note that she is here. OK 啦，就是到此为止啦。